Science excellence. In this series of videos we will work on the textbook Pure Mathematics from Edexcel, and we'll use the resources from Dr. Force Maths. So this is the chapter 1 from year 12 Pure Mathematics, and the chapter name is Algebraic Expression. So let's get started. So the chapter overview is the first section is basic index laws. So then we'll discuss like about the laws of indices as we learn in GCSE as well. We will then we'll do some expanding of brackets, and then after section 3 is factorizing quadratics and cubics, and section 4 we'll do fractional and negative powers. We'll solve the fractional and negative powers, and lastly we'll solve some surds questions. So the first section is index laws. So this is very like the basic thing, if you have some number, we have some number with the power, then this number over here in this example is called the base, and 5 is called the power or the exponent of the number. So on this side or right hand side, you can see we have some laws of indices, which is like if you have it's a times a, and the bases are same, and you have to multiply the numbers, so that means you should consider the single base a, and we need to add the powers m plus n. So similarly, if we have to divide the numbers, the bases are same, so you need to just consider the single base and take away the powers to get the answer. And the next index law is if you have a number with power, and we have again a whole power, that means we have double powers, so you should times the power, so it should be a power m times n. And the last is if you have a b multiplication of the numbers a times b whole power n, then the whole power will apply on both the numbers a power n b power n. So these are some basic laws of indices. Okay, let's see the examples now. We have to simplify a to the power 3. We have to simplify a to the power 3 times 2a to the power 2. So as we know, if you have the double power, so we should times the power, so it will be a to the power 3 times 2 is 6 times 2 times a to the power 2. So we can consider 2 as it is, and a power 6 times a power 2 will be a to the power 6 plus 2, which is 8, because we have the same basis and we need to times the number, so we have to add the powers, so that should be the answer. So you can see we have 2 times a to the power 8. So the next question is, so we have to simplify again 4x cube y whole power 3. So again we have the whole power of 4x cube y, so if you apply the power, it will be 4 power 3 times x to the power 3 times 3 is 9, and y power 3, and 4 power 3 means 4 times 4 times 4, which is 64, so it will be 64 x to the power 9 y cube. So this should be the answer for the next one. So you can see 64 x power 9 y cube. So similarly we can do the next, which is like 2x squared times 3 plus 5x. If you take 2x square inside, it will be 3 times 2 is 6 x power 2 plus 5 times 2 is 10 x squared times x is x cube, minus if you take x inside it's minus 4x minus plus x cube. So if you add the like terms, so 10x cube plus x cube is 11x cube, plus 6x squared is only the term, keep as it is, minus 4x. So this should be the answer for the next one. So you can see 11x cube plus 6x squared minus 4x. Okay, so the next example is x cube minus 2x over 3x square. So if you split the LCM here, it will be x cube minus 2x. So you can write x cube over 3x square and 2x over 3x square. Now x cube divided by x square, so we have to take away the power, so 3 minus 2 is 1, so we will left with x over 3 minus this power is 1 and this is 2, so you're left with 2 over x. So you can see this is the answer, 1 over 3x minus 2 over 3x. So the next is, again we have some more questions. So this section is like test your understanding. So if you want to try this question by yourself, and then I will show you the answer, you can stop the video and solve these questions by yourself, and then you can check the answers. So again, in the first question, first you need to apply the power 2 on both numbers, and then it's a power 5 over a power 2, so it will be a power 3. So when you apply the power 2 on it, so 2 power 2 will be 4, and if you have the double powers, you should times the power, so 3 times 2 is 6 and times by 3a, so 4 times 3 is 12, and a power 6 plus a power 1 is a power 7. And over here again we can split over LCM, which is 2x over 4x cube plus x power 5 over 4x cube, and if you simplify, you will end up with this one, half x power minus 2 plus 1 over 4x square. And you can write even in this way if you take this x power minus 2 down in the denominator. And the next example, again you can take 2x inside the bracket minus 4x cube inside the bracket, and then add the like terms to get this answer. Over here is 2 power x times 3 power x, so the basis the power is same in this case, so you can consider the combined power for both. It will be 2 times 3 whole power x, so 3 times 2 is 6, so 6 power x will be the answer in this case. Okay, so next we have more questions from the past papers. So the question number 1 is, which of the following number is largest? So you can simplify these one, like if you have 2 power 3 whole power 2 and then whole power 3, so you can expand these two first and then you can apply the power. Even you can sub in the calculator to check which one is largest. It's not very important in terms for the exam point of view for now. So again in this question we have to show that n equals to 2 power k times 4 power m times 8 power n, where k, m, n are positive whole numbers. Then n will definitely be a square number whenever k is even, k plus n is odd, k is odd but m plus n is even, k plus n is even. So we need to check which condition is correct. Okay, so if you consider this this over here, n equals to 2 power k times 2 4 power m can be written as 2 power 2 whole power m, so it will be 2 power 2 m over here. So 2 power k times 2 power 2 m times 2 power 3 n. So now the bases are same, you need to multiply the numbers, so you can add the powers. It will be k plus 2m plus 3n. Now n will be the square number if this power is even, right? If you have any number and the power is even, let's say 4, so you can always write this number in the form of a square like that. So this power should be even if n is a square number, right? So if this whole thing is even, so that means 2m obviously is an even thing because it's a multiple of 2, so you can ignore it. That means k plus 3n should be even. So if k plus 3n is even, then you can say the k plus n is even as well, because it's just a multiple of n, so you can ignore it. So that means this condition holds, k plus n should be the even if n is a square number. Again, we have one more question on the expanding of brackets. So over here we have to do the term-by-term multiplication. If you times x with x will be x square, and if you times your x with y will be xy. X times minus 1 will be minus x, then y times minus y times x will be minus xy, minus y times y will be y square, and minus y times minus 1 will be positive y. Now we need to look for the like terms, and we need to solve them together. So it will be x square minus y square. This positive xy minus xy cancel out, you're left with minus x plus y. Again we have expanding of brackets, but we have three brackets in this case. So first you can times two brackets together, and then the result you need to multiply with the next bracket, as we did over here. Like we timed these two brackets first. You can see the expansion of these two brackets is x square plus 5x plus 6. Then you can times x plus 1 with this one to get this, and then we need to add the like terms. X cube is only the term we can keep as it is. X square plus x 5x square plus x square is 6x square. Then 6x plus 5x is 11x, and keep 6x, keep the 6 constant as it is. Now again you can multiply, you can solve these questions by yourself. You can stop the video and then you can check the answers by your own. These are easy and basic questions. I'm gonna just show you the answer and move to the next slide. Alright, so again we have some exam style questions from the past papers. So the question number 1 is, of the following three alleged algebraic identities, at least one is wrong. So you need to check which one is wrong. So you can do term by term multiplication on both sides, and you can check which one is not, which left hand side is not equals to the right hand side, and the answer 2 should be correct. So you can try this by your own. It's easy. Okay, so in this question we have, if x and n are integers, then this result is negative when n is greater than 5 and x is less than 5, negative when n is odd and x is greater than 5, negative n is multiple of 3 and x is greater than 5, and negative when n is even and x is less than 5. So we need to check which condition holds for this result, which condition is true for this result. So if you check the first condition, this result is negative when n is greater than 5 and x is less than 5. So if x is less than 5, then if we put x equals to 4, this will be 0. If we consider x equals to 3, this will be 0 though. So that means the whole result will be 0. If you could consider x equals to 2, the whole thing is 0. If you consider x equals to 1, the whole thing is 0. So the first should not be true, because if you consider any value less than 5, the whole result will be 0, not negative. So if you check the next one, n is odd and x is more than 5. So if x is more than 5, let's say x is 6, and since n is odd, so let's say n is 1. In this result, then if you put x equals to, replace your x with 6, 1 minus 6, and if you put n equals to 1 in a, to power 1, so 2 minus 6 power 2, 3 minus 6 power 3, and 4 minus 6 power 4, and 5 minus 6 power 5. So what we did, we replace our x with 6 and n with 1, because n is odd, n can be any odd number, and x should be more than 5. So we suppose x is 6. So if you check this one, so it's 1 minus 6, which is minus 5, 2 minus 4, which is minus 4 to the power 2, 3 minus 6 is minus 3 to the power 3, 4 minus 6 is minus 2 to the power 4, and 5 minus 6 is minus 1 to the power 5. So you can see this is the negative number, first one. The second one is a negative number but the even power, so the number is positive. This number is negative, this is positive, and this is negative. So you have 1, 2 and 3 negatives and 2 positives. So if you have 3 negatives in multiplication, so positive times negative is negative, negative times negative is positive, and positive times positive is positive, but positive times negative will be negative. So you have 3 negatives actually, so the whole result will be negative. So it means this result holds, this is true, this statement is true, and you can check it should be true. So n is odd and x is greater than 5. Okay, so the next section is factorizing. Informally, factorizing is the opposite of expanding brackets. More formally, a factorized expression is one which is expressed as a product of expressions. So like you can see over here, these are the factors of a cubic expression, right? So factorize as it is the part of three linear factors x, x plus 1 and x plus 2. This is not the complete factorization, but because you can see x plus 1 and x plus 1 is a common factor which is available in both the terms. So it's not factorized because the outermost expression is a sum, not the product. So the basic example of the factorization can be if you have x cubed plus x squared. So you should take, if you take x squared as a factor out over here, so you're left with x from here and 1 from here. So this should be the factorization of this one. And from this expression, if you can see 4 can divide both, so you should take 4 out, and x is a common letter, so you should take x out. So 4x out from this side, from this term, so you're left with 1 minus a divided by 4 is 2. X is already outside, so it should be 1 minus 2y. So you can see this is on its own. Now again we have a quadratic equation and we have to factorize it. So if you have to do the quadratic factorization, we already did this factorization in GCSE as well, so it's just a recap. We have to consider this minus 14, and since the quotient of x squared is 1, so if you times by 1, again it's minus 14. So if you we need to find the two pair of numbers. If you times them, it should be minus 14, and if you add that numbers, it should be minus 5. So if you consider the factors of 14, 1 times 14, 2 times 7 is 14 as well, and these are the factors of 14. And if we consider 2 times 7 as a product, so it is 14, and as a sum, if you have 2 minus 7, it is minus 5. So if you consider 2 times minus 7, it will be minus 14, and 2 minus 7 is minus 5. So this should be the right pair, 2 and minus 7. So our factors should be x. You need to write like that, x and x, because the quotient of x squared is 1, so you can write the factors directly in this case. So we just need to pick these numbers, 2 and minus 7, so it will be x plus 2 and x minus 7. So these should be the factors of this quadratic equation by using the factorization method. So you can see x minus 7 and x times x plus 2 are the factors of this quadratic expression. So but if the coefficient of x k, you can see over here, is more than 1, then the process is different. The easiest way is to use your common sense to guess the brackets, what multiples to give the 2x square, and what multiples to give the constant term of minus 12, and you will get this, because 2x times x is 2x square, and minus 3 times 4 is minus 12. But we can use the proper process to get the factors of this quadratic equation. So the proper method is, if you times this minus 12 with the quotient of x squared is 2, so minus 12 times 2 is minus 24, and over here the quotient of x is 5, so if you add the numbers, you should have 5, and if you times them, you should have minus 24. So if you consider the factors of 24, so 1 times 24 is 1 times 24 is 24, so 2 times 12 is 24, and then 3 times 8, and 6 times 4. But we need to find the pair which follow the sum as well. So if you pick 3 and 8, and they should follow the sum as well, because 3 times 8 is 24, and we need positive 5. So if you consider minus 3 plus 8 is positive 5, and minus 3 times 8 is minus 24, because we need it as a product. If you times the numbers, we should have minus 24. So this should be the right pair, minus 3 plus 8. But we can't write directly the factors as we did over here, because the coefficient of x squared is more than 1. So what we need to do, we need to split this coefficient of x by using these two numbers, minus 3 and 8. So if you consider 2x squared plus 8x minus 3x minus 12, split this 5x by using these two pair of numbers, which is positive 8 and minus 3. So from the first two terms, now we need to do the group-wise factorization. What is the common thing in the first two terms is 2x. So if you take 2x out, you're left with x plus 4, and if you take minus 3 out from the next two terms, you're left with x plus 4. So if you factorize again, it will be x plus 4 times 2x minus 3. So this is the factorization of this quadratic equation. So you can see here again, they explain the same method as we discussed. As a sum we need 5, as a product we need minus 24. So we can split our numbers, split over 5 by using these two numbers, 8 and minus 3. Then we can take the do the factorization, group-wise factorization, and then after final factorization we'll get the factors. So again we have some more factorizations. So the difference of two squares. So the difference of the two squares is like, if you consider this as 4 can be written as 2 power 2 x power 2 minus 9 can be written as 3 power 2, and as a whole it will be 2x whole power 2 minus 3 power 2. Now it is if you remember the formula from GCSE, the difference of the squares, which is a square minus b square, and it's equals to a minus b times a plus b. And if you apply the same formula over here, you have 2x whole square minus 3 square. It will be then 2x minus 3 times 2x plus 3, and this should be the answer. Okay, so next is using multiple factorizations. So from here, first you can see x is a common term. So if you take your x out, you're left with x square minus 1, and 1 can be written as 1 square. So it's again the difference of the square, so it should be x times x minus 1 times x plus 1. So this should be the answer in this case. Okay, so the last one on this slide is the cubic equation, but x is a common factor throughout. So if you take x out, you're left with x square plus 3x plus 2. Now it is quadratic, and we can do the quadratic factorization again as you did before to get the rest of the factors. So the coefficient of x is 3, and if you times the number, we should have 2, and when you add the numbers, we should have 3. So it should be 2 times 1, which is 2, and because 2 plus 1 is 3, so it should be x times x plus 2 and times x plus 1. So this should be the answer. Yeah. Okay, now again you have some questions to do. These are like the same questions of with more difficulty, so you can try these questions for yourself. You can pause the video and you can try these questions for yourself, and you can check the answers after. Okay, the next section is negative and fractional indices. So over here Again, we have some index rules to solve these negative and fractional indices. First, we should remember like a power any term, any number with power 0 is always equals to 1. And if you have a to the power 1 over any number, that means you have that root. I mean, like if you have a to the power 1 over 2, that means you have square root of a. And if you have a to the power 1 over 4, it means you have fourth root of a. And similarly, if you have any like a power 1 over any number, that means you have that root. And again, if you have a to the power m n over m, so you can write this one as a to the power 1 over m whole power n. So a power 1 over m should be the mth root of a and the whole power n. So you can write this in this way as well. And if you have a to the power minus m, and if you bring this down into the denominator, then negative power turn into positive powers. If you have to change the negative powers into positive powers, so you can apply the reciprocal of on that number to change the negative power into the positive power. Okay, let's have a look on the questions now. So the first question is, prove that x power half equals to root x. Okay, so the next question is, prove that x power half equals to square root of x. So if you do x power half times x power half, so we have to add the powers. So it will be x power half plus x half will be half plus half will be 1, so it will be x power 1. And we know, but we know that root x times root x is x. So that you can see the right hand sides are equal, so which shows x power half equals to the root x. Okay, so the next question is, we need to find the value of 27 power minus 1 over 3. So if you if you apply the reciprocal on this value, I mean if you take this to the denominator, the negative power, 27 power minus 1 over 3 can be written as 27 power minus 1 over 3 over 1. Any number, if you divide by 1, will remain same. And if you take this number to the denominator, the negative power turn into positive power, so it will be 1 over 27 power 1 over 3 positive. So it's actually a cube root of 27, and 27 can be written as 3 times 3 times 3, because 3 times 3 is 9 and 9 times 3 is 27, so it's 3 power 3. So if you replace your 27 with 3 power 3, and you have the whole power 1 over 3 on it, so 3 1 over 3 cancel out, you're left with 1 over 3. So the answer should be 1 over 3 in this case. So the next is, evaluate 32 to the power 2 over 5. So it's fifth root, so if you factorize 32, it should be, okay, do the factorization of the 32. So 2 can divide 32. If you divide by 2, it will be 16. Divide 16 by 2 is 8. Divide 8 by 2 is 4. And if you divide 4 by 2 is 2, and divide 2 by 2 is 1. So it's 1 2 3 4 5. So it's 2 power 5. So 32 can be written as 2 power 5, and the whole power is 2 over 5. So then 5 and 5 cancel out, you're left with 2 power 2, which is 4. So the answer should be 4 in this case. Okay, so the next question is, simplify 1 over 9 x power 6 y whole power 1 over 2. So it's actually a square root of, we have to apply the square root on each and every term. So 1, if you apply any power on 1 will remain same. So the square root of 9 is 3, and in this case it's x power 6 then power half. So if you have double powers, you should times the power, so it should be 6 times half, and y power 1 over 2. So what is the half of 6 is 3, so it's 1 over 3 x to the power 3 y power half should be the answer in this case. Okay, so the next is, evaluate 27 over 8 whole power minus 2 over 3. So since you can see the power is negative, so if you again flip the fraction, the negative power turn into positive power, so it will be 8 over 27 whole power 2 over 3. Now is 3, this 3 shows it's a cube root, So the cube root of 8 is 2, and the cube root of 27 is 3, and the whole power 2. So 2 power 2 is 4, and 3 power 2 is 9, so 4 over 9 should be the answer in this case. Okay, so the next question is, if b equals to 1 over 9 a power 2, determine 3b to the power minus 2 in the form k b power n, where k and n are the constants. Okay, so we need to work out this from here. So if you times by 3 on both sides, so it will be 3b equals to 3 times 1 over 9. It will be 3 times 1 over 9 a to the power 2. So 3 times 1 over 9 is 1 over 3 a to the power 2. So we got 3b, but we need 3b to the power minus 2. So since our 3b equals to 1 over 3 a to the power 2, so we should apply power minus 2 on both sides. Since we have to make the b power minus 2 times 3, so we should apply the power first and then times by 3, sorry. So consider this number again, b equals to 1 over 9 a to the power 2, and you apply the power minus 2 on both sides, is b power minus 2, 1 over 9 a power 2 whole power minus 2. So if you apply any power on 1 don't mind, so a power minus 2, 9 power minus 2, and a to the power 2 times minus 2, which is minus 4. So if you take this up to make the power positive, so and you can take this down to make power positive of a as well. So 9 power minus 2, if you take this to the numerator, it will be 9 power 2 over a to the power 4, which is b power minus 2. So 9 power 2 means 9 times 9, which is 81 over a to the power 4, and this is equals to b to the power minus 2. Now we should times by 3 on both sides. So if you times by 3 on both sides, then 3b to the power minus 2 will be 3 times 81. 3 times 1 is 3, 24, so it's 243 over a to the power 4 should be the answer in this case. Yeah, so 243 over a to the power 4, and if you take this up, it will be a to the power minus 4. Okay, so the next question is, let r and s be integers, then you have this expression is an integer if one of the condition holds. So we should solve this, we have to simplify this, and then we can check which condition is we should have to make this fraction as integer. Okay, so if you simplify this, so then 6 can be written as 2 times 3 whole power r plus s, times 12 can be written as 3 times 4 whole power r minus s, 8 can be written as 2 power 3 whole power r, and 9 can be 3 power 2 whole power r plus 2s. Now if you apply the powers on it, it will be 2 power r plus s times 3 to the power r plus s, and then 3 to the power r minus s, and again 4 can be written as 2 times 2, so it's 2 power r minus s times 2 power r minus s over 2 power 3 r times 3 to the power, if you times this 2 with this power, is 3 to the power 2r plus 2 times 2 is 4s. So further, if you can see the like terms 2, 2 and 2, so we have to add these powers because the bases are same and you have to multiply the numbers, so we need to add the powers. So r plus r plus r is 3r, 2 power 3r. So s minus s minus s, so minus 2s plus s is actually minus s. So 2 power 3r minus s, and 3 and 3, so it will be 3 to the power 2r, s minus s will be 0. So in the denominator you have 2 to the power 3r times 3 to the power 2r plus 4s. Okay, so if you have to divide the numbers, the bases are same, so you have to take away the power. So 3r take away 3r will be 0, so you're left with 2 power minus s, and from this side 2r take away 2r is 0, so it will be 3 to the power minus 4s. Now we should, in this case, if you have the negative powers, so we should, and that means we have the fraction, because if you take this down, both the powers will be positive. 2 power s times 3 to the power 4s, but in this case it's not the integer, the fraction is not integer, so we should have s less than equals to 0, because if s is 0, then 2 power 0, 3 power 0 will be 1, which is integer. But if s is less than 0, which is negative, so if negative times negative, that means the power turn into positive, and this will be the integer. So the option should be this, s less than equals to 0. Okay, so now move to the next slide. Okay, so the next section is surds. So a surd is a root of a number that does not simplify to a rational number. If under the square root, if you do not have a square number, that means you can't solve that square exactly, and you will have some irrational decimal number. We will have actually the decimal number with non-terminating decimal part. So the laws of indices are again like if you have the product of the two numbers and both the numbers are under the root, so you can write under the combined root, we can combine the power. So if you can see over here root of a over root of b, so you can again combine the power in terms of fraction as well. So these are some basic results, like root 3 times 2, it will be 2 root 3. So in this case it's 3 times root 5 times 2 root 5, so 3 times 2 is 6, and root 5 times root 5 is root 25, and root 25 is 5, so 5 times 6 is 30. And if you have root 8, so 8 it can be written as 4 times 2, because 8 you can write as 4 times 2, and then you can split the root, and the root of 4 is 2, so answer will be 2 root 2. Again over here we can simplify this. Root 12 can be written as 3 times 4, and 4 can be written as like root 12 can be written as 3 times 4, and we can write this as root 3 times root 4, and root 4 is 2, so it's 2 root 3. And root 27, so 27 we can write as 9 times 3 is 27, and the root of 9 root of 3, and root of 9 is 3, so it's 3 root 3. So over here we have then 2 root 3 and 3 root 3, so 3 plus 2 is 5, so it should be 5 root 3. Similarly you can do term by term multiplication over here, like root 5 times root 2 is root 16, root 8 times root 2 is root 16, and square root 2 times 3 is 3 root 8, and then 1 times these two will be as it is, and then you can add the like terms to get your answer. Again over here you can simplify this. Root 16 is 4, and root 8 we can write as 2 root 2, so it will be then, because root 8, sorry, yeah, so root 8 can be written as square root of 2 times 2 times 2, and it can be written as 4 times 2, so we can split the roots again. So square root of 4 times square root of 2, and square root of 4 is 2, so it's 2 root 2. So 8 can be written as 2 root 2 times by 3 is 6 root 2. So you can simplify this to get this. So 6 root 2 over here, so square root of 16 is 4 root 2, so 6 minus 6 root 2 plus root 2 is minus 5 root 2, and 4 minus 3 is 1, so it will be 1 minus 5 root 2. Okay, so we have more questions on the same topic. Which of the following is smallest? So you can solve these to check which one is smallest. You can even sub in the calculator to check which one is smallest, so it's not even important for the exam point of view. So you can do these one by one. Okay, so the next section is rationalizing the denominators. So here's a surd. What could we multiply it by such that it's no longer an irrational number? So under the root, if you have a number which is not a square number, that means it's irrational. So if you times by root 5, so root 5 times root 5 is root 25. If you have root 5 and times by root 5 again, so it will be root 25, which is 5, so it's no more irrational. So this is the rational number now. So we should times by root 5 now to change this from irrational to rational. Again, if you have 1 over root 2, if you have your surd value in the denominator, so how you can get rid from this surd value from the denominator? You should times by root 2 up and down. So root 2 times 1 is root 2, and over here square root 2 times square root 2, which is square root 4, and square root 4 is 2. So you can see the surd value is eliminated from the denominator. Again, we have some examples to check like how you can eliminate your surd values from the denominator. In this case, you should times by root 2 up and down to get your value to eliminate your surd from the denominator. In this case, we should times by root 3 up and down, and root 3 times root 3 is root 9, which is, so in the numerator we have 6 root 3, and the denominator is root 3 times root 3, which is root 9, and root 9 is actually 3, so it's 6 root 3 over 3, and finally 6 divided by 3 is 2, so it's 2 root 3 is the answer in this case. Similarly, we can times by root 2 up and down, root 7 up and down over here to eliminate the surd value from the denominator. So it will be 7 root 7. Root 7 times root 7 is root 49, and root 49 is 7, so it's 7 root 7 over 7. So 7 and 7 cancel out, you're left with only square root 7. Okay, so in this case, again, if you want to eliminate your surd value from the denominator, so you should just times this value by root 5 up and down. So you will have 15 root 5 over 5 plus root 5. So 15 divided by 5 is 3, so it's 3 root 5 plus root 5, so it will be 4 root 5. If you add these two, root 3 root 5 plus root 5 will be 4 root 5. So now these questions you can try by your own. These are very easy. You can pause the video and try by yourself, then you can check the answers after. So we have like more complex questions on like rationalizing the denominators. So if you times by, so if you want to eliminate your surd value from the denominator, in this case we have to change this sign from positive to negative and times by that up and down to get rid from the surd value from the denominator. So root 2 minus 1 times by this one, so will be this value in the numerator, and over here you can see is a plus b times a minus b, so you can change this into a square minus b square by using difference of the squares. Otherwise we can do term by term multiplication to get your answer in the denominator. Like if it's a plus b times a minus b, which is actually a square minus b square. So square and square root cancel out, you're left with 2, and 1 power 2 is remain 1, so 2 minus 1 is 1. So you can apply either the difference of square, or you can do term by term multiplication. You're left with 1 only, and you can see the surd is eliminated from the denominator. Again, you have more example on the same kind of questions. If you want to eliminate your surd value, in this case you should change this sign from negative to positive, and you need to times this that value up and down. You can see over here we times by root 6 plus 2 up and down, and it's 3 times, this will be the numerator, 3 times root 6 plus 3 times 2 is 6, and again we can do term by term multiplication to get the 2 over here. Is again we can apply the difference of the squares, which is the like a square minus b square. So the root and square root cancel out is 6, and 2 power 2 is 4, so 6 minus 4 is 2. So that's why we left with 2, and the surd is eliminated from the denominator. Again, in this case we need to change this positive sign with negative, and we should times by root 3 minus 1 up and down, and then you have to do the term by term multiplication, and then you will see the surd will be eliminated from the denominator and get the simplified answer. In this case 2 can divide both the numbers. Even if you split your LCM, you'll get this answer. Again, in this case we should change this negative sign. If you change this negative, this sign with positive, and we times by this number up and down, like if you times by 5 root 2 plus 7 up and down, and then if you do term by term multiplication, you will see the surd value will be eliminated from the denominator. So you can see we change the sign, we times by this number up and down. We can do term by term multiplication in the numerator and in the denominator as well, and we will end up with the no surd value in the denominator, and you'll get the simplified answer if you work out the like terms, like 30 and 28 is 58, and these two values you can add together to get the final answer. So we have some more questions for the practice. You can try these questions by your own. You can pause the video and you can check the answers after. So these are again some more questions from the exercise textbook. So you can try these questions again, and you can check your understanding and you can check your answers after. Okay, now we reach to the last question of this lesson, which is like a difficult question. So let's try to do this question. So we should simplify the left hand side first, then we can compare with the right hand side. And on the right hand side we can see we have 3 to the power 1 over x. So we should try to change these numbers to the power of 3. So 9 can be written as 3 to the power 2 and whole power 1 over 4, and 27 can be written as 3 to the power 3 whole power 1 over 5. And if you simplify this, the other side is actually 3 to the power 1 over x. Okay, if you simplify the left hand side, then 2 times 1 over 4 is 3 power half, and this will be 3 to the power 3 times 1 over 5 will be 3 power 3 over 5, and the right hand side is 3 power 1 over x. Now you can see on the left hand side is 3 power half divided by 3 power 3 over 5, so we should take away the powers. So 3 power 1 over 2 minus 3 over 5 equals to 3 power 1 over x. Now we have to solve this fraction which is in the power. So 1 over 2 minus 3 over 5. So if you times this by 2 up and down, and times this by 5 up and down, so 5 times 1 is 5, so it's 5 over 10 minus 6 over 10. So it will be 5 minus 6 over 10, and at the end we will have minus 1 over 10. So it should be 3 to the power minus 1 over 10, and which is equals to 3 to power 1 over x. Now we have the same basis on both sides, the number are equal, you can equate the powers. So minus 1 over 10 equals to 1 over x. So if you apply the reciprocal on both sides, so x will be minus 10. So this should be the answer. Yeah, so this is the answer, and this is the end of the lesson. Thank you for watching, and in the next lesson we will do chapter 2 of the AS Pure Mathematics book. Thank you.